107. Operations with scientific notation. First, we'll do a little review of scientific notation. So scientific notation is a way to take incredibly large or small numbers and shorthand the way that we write them. Notate means the way we write something. Scientific, because it's often used in the scientific community when we're looking at large distances, like the distance between a planet or something really small, when we're talking about maybe the size of an atom. So we'll just take some random number. Let's do 348,500. And we're going to put that in scientific notation. So right now, my decimal would be over here on the far right of that number. For scientific notation, we want only one digit in front of that decimal. We want to have a number between 1 and 10. So I am going to move the decimal all the way over here so that it's right after the 3. So that means I have to move my decimal 1, 2, 3, 4, 5 places. So I will write this as 3.485, because that's where I want my decimal to go, times 10 to the 5th power, because that's how many places I move the decimal. Now we'll look at a really small number. And I think I'm also going to move this because we might need some space over there. So now we'll look at a really small number. Let's look at 0.0027. So this time I need to move my decimal the other way. So when I have big numbers, I'm going to have a big exponent. When I have a small number, it's going to be a negative exponent because I'm moving my decimal the opposite direction. So here I'm moving the decimal 1, 2, 3 places because I want it to be between the 2 and the 7. I want there to be one digit before the decimal. 2.7 is a number between 1 and 10. And I would write this times 10 to the, and because I moved it 3 places to the other direction because I had a small number, it will be the negative 3rd power. So let's look at things that are in scientific notation. Possibly we'll look at yes or no. So if I have something like 34.8 times 10 squared, it might look good. I have a decimal, I have times power over 10, but this 34.8 is not between 1 and 10. I have a 3 and a 4 before the decimal. So that would not be in scientific notation. So let's look at another one. What about 7.86? So again, at the surface, this looks good. I only have one digit this time before the decimal, right? But I don't have a power of 10. So that would not be in scientific notation. How about something like this? So this one might look weird, 7.3 times 10 to the 0 power, because I have a 0 power, but I have one digit, a 7 only, before the decimal. 7.3 is a number between 1 and 10, and I have times 10 to a power. It's just the power happens to be 0. So that one would be in scientific notation. So sometimes we need to do operations on scientific notation. So remember, operations is when we add, subtract, multiply, and divide in math. That's what we commonly think of as our basic operations. So we're going to try to figure out the easiest way to multiply these. I mean, one way would obviously be to go through and write out what 2.2 times 10 to the 3rd is, make it a standard form number, a big number. Do the same thing with 4 times 10 to the 5th, write it all out, multiply them, and then convert it back. But in math, we're always trying to figure out an easier way. So let's first think about what's really happening here. This X right here is a times sign, right? And then my parentheses, I'm showing multiplication, and then I have another multiplication symbol over here. So I'm going to write this a different way, just because I think it'll look easier to me. 2.2 times 10 to the 3rd times 4 times 10 to the 5th. So what I've done is I've taken out those X's, and I've taken out the parentheses and just put everything with the times sign that we're used to using. Now I know in math that I'm allowed to multiply things in any order. I have 4 numbers that are being multiplied. Let's choose the most appropriate order. So I'm going to multiply the 2.2 times the 4, and then I'm going to multiply the 10 cubed times the 10 to the 5th. And I'm going to group them so that I'm multiplying this part and I'm multiplying this part. So let's see how this works. 2.2 times 4, well, 2 times 4 is 8, so this will be an 8.8 times. Over here, I have 3 factors of 10, and I have 5 factors of 10. So if I have 3 factors of 10 and I'm multiplying by 5 more of them all together, I will have 10 to the 8th power. So we've just found a really easy way to kind of shorthand this. So let's summarize over here. So what I did was I took those number parts and I multiplied. And then I took my exponents and I added them. So let's use our shorthand method on the next one. So now I want to multiply 3.1 times 5. Well, 3 times 5 is 15. And the 0.1 times 5 would just be a 5. So I have 15.5 times 10 to the, add my exponents, I get 6. Oh, I've got a problem on this one, though. I'm not really in scientific notation because 15.5 is not a number between 1 and 10. I have more than one digit in front of the decimal. I have a 5 and a 1. So I really need my decimal to move one place over. Since my number was too big, I'm going to have to add 1 to my exponent. So when I'm changing small numbers, I subtract. When I'm making bigger numbers, I'm adding. So this will now be 1.55 times 10 to the 7th. So sometimes you will have to adjust those numbers after you multiply. So now we'll look at division. So now I have 5 times 10 squared over 2.5 times 10 to the 5th. So something that I like to think about is when we multiply fractions, we multiply straight across. So we could really write this as 5 over 2.5 times 10 squared over 10 to the 5th. Because if I was going to go back and multiply this together, I would multiply the 5 and the 10 squared in the numerator. I'd multiply the 2.5 and the 10 to the 5th in the denominator. So those two are going to be equivalent. So now I'm going to reduce each fraction separately. So 5 divided by 2.5, well, I know there's 2.5. I can double that and get 5. So this is going to be 2. And then over here, I've got to think back to my rules of exponents. So when I was multiplying, I know I had to add those. Let's think about what this means. And sometimes it helps with the division if we visualize that and write it out. So 10 squared really means 10 times 10. 10 to the 5th means I have 5 tenths. So we can take away 2 of those factors because 10 divided by 10 is just a 1. I'm left with 10 times 10 times 10. So I have 3 factors of 10, and they're in the denominator. So remember, if I want to get them out of the denominator, because I can't write this as times 10, 1 over 10 to the 3rd. That's just not scientific notation. If I want to get that out of the denominator, I need to change the sign on the exponent. So this will be 2 times 10 to the negative 3rd. So let's see if we can figure out a shorthand way to do this. I took the 5 and the 2.5 and I divided them. And then let's look at what we did at the exponents. I have a 2 and I have a 5. So it's really like I subtracted and started in the numerator and did 2 minus 5 and got negative 3. So now we're going to use those rules and we'll make some notes on the next one. Let's get this out of the way. So we found that we're going to divide the 1.5 and the 3. And then I'm going to take my exponents over here and I'm going to subtract. And the order that we subtract in is really important. We're going to do numerator minus denominator. So I'm going to write top minus bottom. We'll keep our vocab really simple. Subtract exponents. So 1.5 divided by 3 really makes me think of 15 divided by 3. 15 divided by 3 would be 5, but I have a 1.5. So this is going to be 0.5. And then I subtract my exponents. 9 minus 6 would be 3. But now I don't have scientific notation again. In front of my decimal, I have a digit, but it's 0. So that doesn't really count. After my decimal is that 5 there. So I'm going to have to move over that decimal. 0.5 is not a number between 1 and 10. So if I move my decimal this direction, because my number was too little, I'm going to have to subtract 1 from the exponent here. So now we'll have 5 times 10 squared. So we've done multiplication, division. Now we're looking at adding and subtracting. So our method for adding and subtracting is going to be first that we're going to change. So both have the smaller exponent. So I'm going to leave 3.5 times 10 to the third the way it is because it has a smaller exponent. And I'm going to change this one to 10 to the third. So how in the world am I going to change that? Well, if I have 10 to the fifth and I need to change it to 10 to the third, I'm going to have to lose 2 of those factors of 10. So if I want to subtract, I'm going to move my decimal this way. And I'm going to have to move it 2 places. So if I do 10 minus 5, then I'm going to get a 3. So I'm going to have to add a 0 in here in order to get 2 places. So this will now be 890 times 10 to the third plus 3.5 times 10 to the third. So now that I've got these together, I'm going to add the 890 and the 3.5. So I'm going to go to my scratch paper. I always do my scratch work off in the margins. And when I add them, I need to be really careful. The 3 should line up with the 0 because my decimal would be right here. Decimals always line up. So we're adding 3.5. So let's see, that's going to be 890. It looked like it was going to be difficult to add, but it was really easy. So our answer is going to be 893.5 times 10 to the third. Okay, so let's go to our steps over here. So we changed, so both have the smaller exponent, and then we're going to add or subtract. We did that part. But now you're probably noticing that our answer is not really in scientific notation. 893.5 is not a number between 1 and 10, and I have 1, 2, 3 digits before that decimal. So I'm going to have to move my decimal 2 places. So I'm going to have to add 2 back in, and we'll go ahead and fix it. Now we'll have 8.935 times 10 to the fifth. Some of you might be noticing a different way that you might handle these problems that you think would be easier, and that's fine. Try your method. See if you get the same answer. This isn't necessarily the method that I would use for these, but it is a method that will always work. And I find that if you're adding numbers that aren't big decimals, adding something like 890 and 3.5 is easier for us most of the time than working with decimals or really giant numbers. So let's write change to scientific notation. That's going to be our last step. So we'll look at one more. This time we're subtracting. So I need to change the 8, that's my bigger exponent, to a 5. So I'm going to have to subtract 3. So I'm going to have to move this 1, 2, 3 places. I'll have to add a 0 again. So we'll have 7820 times 10 to the fifth minus 9.1 times 10 to the fifth. So it's interesting. At first, you might have thought, well, if I'm doing 7 minus 9, my answer is going to be negative. But really, once we change them so they both have the same 10 to a power, they both have 10 to the fifth, I'm doing 7,820 minus 9.1. So not a negative answer at all. I'm going to go to my scratch work again here, 7820, and I'll put my decimal at the end because it's going to help me line up the 9.1. And this time I'm subtracting. So I'll fill in a 0. I can't do 0 minus 1, so I need to make this a 10. Oh man, look over here. If I make this a 10, then this is only a 9. Like, we got all kinds of stuff going on here. So now we need to subtract. Oh, I got to borrow from that one also. We have to keep carrying that down. And I have 7, 8. This is now a 1. This is now a 0. So we get 7810.9. Let's do that. 7810.9 times 10 to the fifth. And then, of course, we're always going to change back. So I'm going to have to move. I have a big number, move it 3 places this way. So add 3. And now I have 7.8109 times 10 to the 8th. This is the end of our 107 notes.